No turning back now, we're going. Madeline, you do not have any right to throw tomatoes at me, no matter how bad or good or indifferent I make you, okay? Always do a shout out to your fellow coworkers. Well, good morning, everybody. This is, I hope you all have a wonderful show this year. This is the 27th straight NAB for me, and I'll do 3 more, and then I have no promises after that. So I really appreciate your time. My name is Tom Ohanian. I'm the media segment strategist at Cisco Systems, and I've been doing the media and entertainment thing for quite some time. I was on the founding team at Avid Technology and invented the first 3 products that came out of the company there. And I've been at Cisco for 5 years, working on really the virtualization of a physical layer to be able to create virtualized facilities and workflows that lend themselves to great flexibility. So that's really the what I'd like to talk to you about. Everything I'm going to tell you today is not fantasy. It's not technology demonstration. These exist today. We have these functioning at customer sites, doing some pretty amazing things. And but the backdrop to it and why we're doing it and how they actually operate and what you should consider in terms of being able to carry this off are really the things that I want to go through. The presentation, after my presentation, my colleague and good friend Biren Gandhi is going to talk to you about secure IP video and everything associated with that in using drones. And I'll introduce Biren because his, he is a distinguished engineer at the company. So with that, let's talk about how to create a virtualized zero-fixed facility. Now, just to get some ground rules, zero does not mean free. It would be nice if it did, but then again, you'd have far fewer manufacturers around. But it does mean the movement of hardware and software to environments that may be geographically separate from the facility. It could mean on-prem private clouds for security reasons or for reasons where the file sizes, bit rates are just too massive. You start to get into an 8K, 60p, 16-bit world, we're talking about 12 gigabytes a second, right? And so there's not a whole lot of time to be moving that off premises. So just keep that in mind, right? So again, sort of motherhood and apple pie here in terms of why this is happening. It's happening because of the wonderful experiences that consumers have and also the requirement to be able to be highly reactive. And so all of our customers are facing this. We don't need to spend 40 minutes on this. It's fairly straightforward. On the other hand, service velocity, flexibility, having to have move from things that were purpose-built to things that lend themselves to flexibility are very important. This is the chronology that we are tracking at our customer level and the industry level. Now it's interesting because when you look at a lot of our web-based companies or when you look at the companies that you may interact with from a social network perspective, the LinkedIn, the Facebooks, the Netflixes, the Amazons and so forth, they're clearly on the right-hand side of this diagram. The infrastructure is virtualized, applications are loaded and so forth. But the majority of certainly customers on the broadcast side are on the left-hand side. There are appliances and racks or some form of proprietary appliances, hoping for this convergence over. And we're squarely sort of in the middle now in terms of where the bullseye and the target is for the things you're starting to see at this show, right? People are talking about IP media fabrics. They're talking about the SDI to IP transition. You're actually starting to see it go from discussions into demonstrations. And this middle part is sort of that next phase. So think about the largest nonfiction programmer in the world, or think about facilities that are 7 years old, beautiful, brand new, essentially facilities that will run out of power and space in 2 years. Why? Because they're successful, but they have been built to do certain things. And again, I'm old enough and have been doing this long enough to know that I had a wonderful time when we only created 2 broadcast formats, right? Now, immediately when HBO Go announced web, mobile, portal, different formats, about 100, 105 formats. Blake knows this. He lives it every day. 300 formats, kind of status quo. When you have a crazily successful property like a Frozen, 35,000 formats, right? Subtitles, bit rates, formats, aspect ratios, it gets interesting. And of course, facilities were made to do very specific things: reliability, predictability, and they need to lend themselves to this kind of flexibility. Sort of the last bastion for SDI is really in that middle section, the studio and post, right? Matrix routers and so forth and so on. That's really what this transition is going to unleash. The irony, of course, is that the consumer is already in an IP environment and has been there for quite some time. We have to catch up. All right, so I want to talk a little bit about let's move away from the, why are we here, to the, okay, we're here, how are you going to actually build something? What do you need to think about? Virtualizing an infrastructure really has a stack associated with it. Now, one could argue that what I've called these things could be called different things, but in any environment, you're going to have these pieces. These 5 buckets are going to exist, and we'll talk a little bit about them. So the physical layer, certainly, we'll talk about that in an upcoming slide. Then there's a virtualization layer. This is something that's virtualizing that physical layer and making it available. Okay, so the virtualized LANs, the IP media fabric, the computational requirements, virtualizing those and making them available as if you would have literally a roll-away rack that had all of those components in there. There's no rack anymore. It is a virtualized, if you will, container of the physical layer. The applications obviously are the things that actually are the workhorses, right? These are the applications that are doing editorial, transcoding, QC, and so forth and so on. They're the workhorses. Those are the things that people buy, right? I mean, nobody ever went out and bought infrastructure for infrastructure's sake. They buy solutions that the creative people require, and then sort of optimally figure out, what the infrastructure is that should best be used. You need some form of application control, right? Because something is going to tell these applications to go and do something, and workflow is nothing more than n number of applications strung in a very specific sequence to build a workflow. That could be ingest, so I ingest it, I transcode it, I QC it, I stage it, I've got an application that plays it out, and that is my broadcast pop-up channel, right? So, and then the E2E orchestration. These are orchestration systems that do that, right? They do the sequencing. And lots of products out there, a lot of the applications have their own orchestration engines and so forth. But when you actually look at this in terms of how the industry is going and will go, it's going to stack up in this way. So let's talk about the programmable physical layer. And this is not a new idea in terms of people wanting to do this, but it's always been a case of, well, you really need the SDI to IP transition to happen. You need the virtualized compute environment or the stateless compute environment to happen. And then we need to rethink how storage actually works. So let me spend a little bit of time on this. Obviously, this is what I'm calling the physical layer. It consists of these resources. Listen, you need servers, you need networks, and you need storage. I mean, it's the bottom line, right? Coordinating them all, virtualizing those, and then making them available to a workflow is really what we're concentrating on here. And I wouldn't downplay the security layer anymore, right? Because again, the classic thing is nobody ever hacked into an SDI cable, right? I mean, you could unplug it, and that has certainly happened. Right? We've seen glitches on air. Stuff happens, right? But the fact is, you think about it now, you've got a priority link, you've got a 10 gig link that's being used for priority purposes, and someone jacks into it that is not supposed to jack into it, or is suddenly sending a 6 megabit file, a 6 gigabit file, and suddenly something that should have had priority doesn't have priority anymore, and something that really should have happened doesn't happen. So security has to be throughout this whole process. Security across the physical layer, and obviously access controls. You'll hear this in terms of deterministic networking, who has control, who has access, what should be on the link, what shouldn't be on the link, and so forth. We would kind of take it for granted, but when you actually bubble it all out, there's probably 20 different things you have to be aware of that are taken for granted in the SDI world. We haven't had to think about it. Now you have to think about it. Stateless computing is very important because what you really want is you want the ability to load a profile onto that metal and have that metal take along the characteristics, take those characteristics of what the profile requires. But to do that, you need MAC addresses, worldwide name values that can be moved via software. And servers that obtain their identity based on the needs of the application have to be supported. So you can think about this as, all right, in a best situation, I've got 160 compute nodes available to me. I have 100 gigabits of network capacity. I have 800 megabytes per second of storage capacity as a physical layer. And then you're going to carve out sub-pools of that layer and make them available for workflows that are different. In this case, the physical layer will flex to the different workflow demands. And that's really what we're going for. Network policies, can be difficult to automate. They are handcrafted in many cases. You open up an IT ticket, you're waiting for someone to create a LAN for you or a virtualized LAN, and so forth. But once you start to unleash, NFV, network function virtualization, it will virtualize these main network functions, and you can put them into policies. And once you can put them into policies, you can automate them. And again, they become part of that software profile that starts to indicate what your environment should be. Now you're going to see this as I show you how you actually build the pop-up channels. Okay, there are many people who have built facilities, many people who work in facilities, and you know how this works very, very well. We're building a facility that does control room, we're building a control room facility. We know how that works. We know that there's there are ingest components, transcode components, there are editorial components, there are machines in here. We have, tens of thousands of cables and so forth. It's kind of interesting. If you see this, the EVS OB van that's all IP, there's about 200 cables in that thing. That's it. And it's probably going to be far fewer, as time goes by. So I encourage you to look at that. They're a good partner of ours. See, I threw out my pitch. Madeline, I get extra points for, talking about ISVs. Madeline's not even listening to me. All right, so this is what we have. Here's where we need to get. Let's take a new architectural approach to this, okay? Let's start talking about the physical resource section that specifies the sustained data rate and the throughput requirements based on what you're trying to achieve. So we have a capability. We know what our capacity needs to be. We know what our compute resources have to be, what the network, these are all sustained. Like you have to guarantee to me that I'm going to have these, or my ingest staff is not going to be able to perform. We're going to miss a feed, right? And the same goes through. If we start thinking about it this way, in a virtualized environment, we have really great capacity planning. The dirty little secret around here, people don't tell you about, is that in general, people say that they're very, very highly optimized in their environments. The fact is they're like 20 to 30% over-provisioned and underutilized. And think about why. If you're a news organization, you have like 50 transcode engines for peak. Off peak, you need like 18. It's kind of the ratio. So is anyone going to say, well, we can get by with 18? Of course you can't. And that's why if you start planning in this way, you have tremendous flexibility. And then once you have that planning and you have that, again, that chunk of physical layer, the intelligence is all in how you converge the physical layer and get it ready to receive that software stack. Now this isn't like all baked yet in the sense of all applications out there in this environment lending themselves to virtualization. They're not all there. That's a journey that we're going on as an industry. We'll talk about that. You deploy the applications. The physical layer takes on the characteristics of what your capacity planning was. And the beauty here is that when you're done, they're released back. So why would you build a control room that just is a control room, right? You build a media data center, take this approach, and just like anyone who follows the sort of history of Turing machines, it's really that applied to a media environment. So let's assume the resources. What you're looking at here is the template. I'm actually going to show you this. So this is a template that's created. In this case, it's an OpenStack heat template. And it's actually designed to indicate what are the MAC addresses of the servers, what are the virtual interfaces to create the VLANs, where are the storage subsystems, how much actually do I need, because I'm going to build a workflow that's dependent upon this recipe that's going to be pushed to that physical layer. We push it there, and then the VLANs are automatically created. The network topology is evidenced. We're going to also push the virtual machines. We'll launch the virtual machines, and then the applications that are needed that have to be placed on those VMs to do the actual workflow. And here's kind of tricky issue here, right? Some applications in a bare metal environment, some applications in a VM environment. And again, as you go through the show, you'll start to see, and as you ask the questions, does your application work under VM? Do you have plans? Is your application only, is it optimally running in bare metal versus VM? And this is a journey that we've been taking with a lot of our ISV partners, because you start to see the possibilities and also some of the limitations. I'll give you a practical example. We have a customer, they are contractually obligated by the Motion Picture Association of America to do bit level checking when they move content over a digital network. Put an MD5 hash algorithm on it. The thing takes 6.5 hours to run in a single stream environment. And it's 200,000 DPX files. 10 VMs launched, it's 38 minutes. You can have that kind of magnitude, but it's definitely your mileage may vary type of situation, because again, not all applications lend themselves to that. Some are more compute intensive, some are GPU intensive. You actually have to be able to support both. So once this happens and you move the profile to the physical layer, you launch the VMs, you launch those applications, and you can see on the screen the kind of data that you can see being consumed. So in this case, this is a Imagine Versio virtualized playout application running on Cisco UCS blades, consuming a certain amount of physical resource to run, all specified in the template. So it's very, very rigid in the sense that it's guaranteed to work and not underrun, if you will, right? Max, you like the word underrun from your history. And what's beautiful about this is that when it's finished, really elasticizes. It goes back into the resource pool. And you can actually see in your physical environment where the blades, chassis are located as well. These are all available via open APIs. So when you do that, you can start to time slice and activity slice the physical layer, which is really what we're trying to do here, right? We're trying to virtualize an environment and say, I've got a group that's doing transcoding on this physical layer. We've got the profiles. They've been moved over to the physical layer. It's going chunking along and doing things. And in this case, I've got 16 available compute nodes. 3 nodes are dedicated to the pop-up channel. The other 13 are just cranking through transcode stuff. So I'm going to show you, and again, like I said, there's no technology demonstration here. This stuff is working. You can see it in our booth just over the way. This is actually operational at customer sites. This is, I'm not going to say it's the most beautiful GUI we've ever done in our lives, but you can build GUIs based on the APIs that are northbound and southbound, talk to the physical layer. and obviously are purpose-built. We chose a very specific workflow to build a GUI, and that was deploying a pop-up channel. And so what happens here is you give it a channel name, you load the template that I've shown you earlier. The physical layer becomes virtualized and converged. So you have your CPU, you have your storage, you have your network VLANs created. The VM is launched with your pop-up channel, points to the storage that has the files, and obviously the VM that's running, in this case Versio, has a playlist. Now, that's all good, but what if you have more resources, or you run out of resources that are local to you, and you have interconnect to another one of these virtualized data centers? You can burst, right? And so this is really trying to adjust the whole issue of, I've got resources here, but I can't tap into them. I either can't tap into them because I can't link to them, I can't tap into them because there's no network between them, I can't tap into them because I don't have security privileges to get in there. But if you plan for that, and you have that fallow capacity as you follow the sun, which we've tried to do for years in other industries, you can actually do this. And so what we've done is, actually at the show, we have, obviously there's no hardware here, we're all tapped into 4 data centers that are running around, including Toronto, and we can actually overflow work. Yeah, you have to make sure the actual essence is there, or you can tap into that essence if the pipe is big enough, and the playlist. And so you will then tap into that, utilize those resources, and you can deploy a pop-up channel from any number of data centers that you want to, in this case. The beauty here is that you can utilize the resources for anything you want. If it's a Transcode pop-up channel, if it's not media specific, you can do that. And one of the things we've always wanted in the business has been, show me exactly what I used. Billing purposes, planning purposes, capacity planning purposes, fault tolerant purposes, and so forth. And here it's incontrovertible, right? I mean, these are, you know exactly how much time you were spending. Now, the industry at large, certainly, you're starting to hear these conversations of, the customer vendor community. What are your plans to virtualize? What are your plans to do flex licensing? What are your plans to do transportable licensing, aka no physical dongle, right? The physical dongles don't work in virtualized environments. You have virtualized dongles, certainly, flex licensing, transportable licensing, and for some manufacturers, the thing that they certainly aren't necessarily had to hear in the past, which has been, I want to pay as I go, right? I want to be billed based on what I've utilized of your application, as opposed to buying the application and then paying you 20% maintenance on an annual basis. These are models that are going to change very, very rapidly when you get into these environments. If you start to have multiple data centers with a beefy backbone and be able to virtualize these applications and create ad hoc pop-up channels or whatever else it is, you want those licenses to float around so that you can follow that clock. So again, what I will simply say is that we've gone past the sort of, in theory this could work, show me that you actually did it, to it works, it's operational, linear play out, broadcast channels, where the money is, operational today, running in data centers based on these constructs. So the first thing I would say is, as I wrap up, is if you have any questions, you can certainly ping me on the address. Be happy to share the presentation with you if you'd like it. And the first thing I would like to do, of course, is I want to thank you for your time. But the other thing I want to do is I want to introduce the next speaker, who is Biren Gandhi. Now, Biren is a distinguished engineer at Cisco. He is a corporate strategist working in our corporate strategy and technology team. He's a big deal, but he's very, very passionate about his subject, which is secure IP, and data in drone environments. So thanks for your time. I'm going to hand it over to Biren.
Thanks, Tom. So as we see, like drones are being used more and more in the media industry as a whole. So what Tom presented was more of a monetizable, in the works, operational, completely proven out to customer site solution. What I'm going to present is more of a work in progress type of thing. Part of it is working, part of it is still being created as we speak. And mainly it's because of the regulatory limitations, technological limitations, environmental ecosystem limitations. But those things are evolving pretty soon as we speak. So I'm part of Cisco's corporate strategic innovation group, and we try to do is like focus on these kind of futuristic technologies, including drones and blockchain, virtual reality, augmented reality, and many more in the pipeline, but try to accelerate them by various means, build, buy, partner, invest, co-create joint solutions with our partner customers, whichever way it works. But try to accelerate those futuristic technologies and try to include them in Cisco's portfolio moving forward. I mean, that's the kind of a primary thing we work for. And drones are a very big deal. I don't know how many of you have caught more recent AUVSI, which is like a drone consortium, big organization. They released a dashboard report very recently. And media applications were on top of the line, like top 10 out of top 10, 3 or 4 were media-centric applications of drones. But if you look at like what it takes for enterprise deployments of drone, media, or any other vertical for that matter, so our friends on the left-hand side, our friends at Aerial Strategies, they have done a pretty good analysis of a workflow, like what it takes. It's not very easy to incorporate and integrate drones into the workflow as of today for a number of reasons. I mean, there is a lot of pre-planning that goes into. You have to do proof of concept, actually the scenario planning situation, how the data flow is going to work, who is going to be responsible for capturing the data. Do we have enough bandwidth, high quality, to capture the data in the field where we are going, especially for live events or for pre-recorded scenes and all that. So finding out all those details is very cumbersome task today. And businesses typically have to engage with multiple entities, which is a very cumbersome, convoluted integrations. Starting from finding out appropriate drone service provider, or finding out, okay, what are the sensors apart from camera. For obviously from a media perspective, camera is the single most important thing. But when you're flying things around, especially in an autonomous manner, there are a lot more sensors that go along with that. For gimbal control to the temperature, wind sensor, and how to align better, how to focus and zoom on the right subject, right entity, while having the effective data transfer going through seamlessly. And what if you lose the connectivity, just you're going behind the building, behind a small hill or mountain, what happens? So those are like very complex interactions. You have to work with telecom service providers to make sure like right connectivity is there, work with integrators, and like a lot of parties you have to interact with, which is like a cumbersome thing. And that's one of the reasons why drones are still not becoming mainstream in today's media coverage. So what if we, okay. So the classic challenges are ranging from legal to the scaling, operational, data-centric challenges and all. But I mean, just like thinking about legal challenges, like FAA is barely giving out 333 exemptions for commercial drone flights to slightly about like 4,000 or so in the last few years. And that's the maximum in the last year out of that. Insurance coverages, liabilities, public safety, security, privacy. There are tons of challenges, but how could you overcome some of those challenges in a nice way? For example, time, operational challenge, like time it takes to capture the coverage. If you are covering live event, obviously there is no latency, no gap. You would like to cover it as it happens in real time, pretty fast. But time it takes to perform the drone operation is not that mature just yet. So how do you balance those things out? Another challenge is like a compute. Where do you run the computation? I mean, Tom mentioned like humongous media streams. Yes, we can do a lot of things to the OB vans and other players, but going to the cloud may not be an option every single time, depending on the lack of connectivity where you are operating, where you are capturing the stream from. So how do you maximize like some of the technology capabilities to overcome these hurdles and challenges in the field? Or scaling, like different geographies, when you're trying to operate under different physical environments, you have to work with different players, different service providers. So like how do you scale those standard operating procedures in a unified way across these different players? It's still a big challenge in its own way. So what we are trying to propose and what is in the works is more of a platform-centric approach. So imagine like you have like these three elements: the drones or the birds, the connectivity element, and the boxes on the ground side, which is kind of processing the data in the field before shoving it out to the cloud. So they may be OB vans or some field computers, whatever you call it. Like, and we tend to refer them as fog computing boxes. But imagine like you had a drone agnostic solution, a payload agnostic solution. So it doesn't matter which kind of camera you plug in a drone, doesn't matter which kind of sensor you plug in a drone, just bring it on. And you can use for different applications. If it's a media-centric applications, obviously there is like one set of sensors that go in. But if it's altogether a different vertical, agriculture, precision agriculture, for example, like windmill inspection as shown here, or smart cities or smart communities like buildings in an urban area, different kind of sensors like proximity sensors and Bluetooth LE, and they go. So how do you have different applications? So application enabled platform. So you should be able to, like iPhone, like simple drag and drop sort of app store model, pick an application, drop it for a given purpose, run that, and when it's done, just remove it or leave it around, drag another application if you want to have drones for deployed for another purpose, and go on and go forth from there. So you have to have an app-enabled platform. So drone agnostic, doesn't matter which manufacturer's drone, you should not be locked into one particular manufacturer's drones. There could be thousands, right? Do it yourself, who cares? So build a custom one. So drone agnostic, payload agnostic, app-enabled platform, that's like one pillar. Second pillar is the smart communications. Every single time you cannot rely on the satellite connectivity as the single most important source for the backhaul data. It's costly. It may not be available even every single place you go. So you have to have graceful degradation of the communication channels. If Wi-Fi is available in urban areas, why not use it? Or in some cases, New York-like places, LTE is much more powerful, much more ubiquitous than Wi-Fi for that matter. So use that. Whatever is the most efficient and effective way of communication, just use that for your purpose. And you always need to have the secure digital IP connectivity between the both endpoints, like drone to the ground station and ground station to the cloud whenever it happens. So that security is another big deal. And the third part is it's a self-contained fog computing boxes which can sit on the ground wherever you go. If you are covering an event somewhere like a disaster event, for example, earthquake in the middle of nowhere, where the whole infrastructure is collapsed right now, what do? You cannot take the coverage and take the footage and bring it to the mains, upload it to the cloud. I mean, it would take a lot of hours before your consumers could even able to see those footages. So what can you do? You start processing in the field itself, irrespective of the connectivity. You should not be relying on the cloud or backhaul connectivity for processing the data, editing and all that. So you should be able to do that all in the field. And it should be self-contained, solar-powered or wind-powered, whichever way. So we are working on some prototypes of building those self-contained edge, fog, and cloud hybrid horizontal architectures which would facilitate this kind of behavior. And on top of that, you should be able to capture many different verticals, not just the media, journalism, and news coverage or live events, but precision agriculture, or safety, security, surveillance, remote inspections, which is a very big deal, or collaboration, for example. How can rest of the world see drones' point of view? If you're flying it in US, how can somebody see sitting in Europe or Australia? In fact, we had done a similar demo at NASA last year, where the drone's first-person view was integrated into Cisco's telepresence and WebEx system. So anybody, whoever could join a WebEx call, yes, they could see exactly what the drone camera was seeing. So those things are obvious, like very seamless business transformation enabling technologies. And on top of that, above all, it has to be FAA or any other regulatory body, whichever is active in different geographies, it has to be compliant operations. Right now, most of the noise is coming from consumer area in the drone specific vertical. And FAA is under pressure to kind of bring out those guidelines for public safety, security, keeping in mind the privacy concerns of like whenever somebody is filming, okay, do not film over my house or do not film over my swimming pool, whatever that is. Like, so those concerns, keeping those restrictions and including like not just permanent flight restrictions, but the temporary flight restrictions also. So how can you cannot, as a business, you don't want to deal with all those one-off things every single time you perform a drone operations. Obviously, it's none of the core business or core competence you stand for. As a business, our job should be to focus on the simplest, like hand over, delegate all the mundane tasks to somebody else and focus on the core competence. Why do we exist? What is the core purpose here? And that's where like Cisco's vision comes into picture in a big way. So this three-step process, so what we are trying to do is have a three-step, like first part is building a platform, core platform, which is edge, fog, cloud, hybrid platform, enabled by various applications, enabled by smart connectivity on all that. Unleash the smart APIs and developer ecosystem around that, not just the individual developers, but powerful system integrators and partners and all. So unleash that ecosystem so that everybody can make money together, everybody can really have a win-win scenario there. And the third part is really have a giant scale of infrastructure-powered ecosystem. So we are working closely with NASA and FAA as they are bringing out these various flight regulations and commercial regulations on the drone flights. But recent Cisco's acquisition, Jasper, that has like connectivity and plans, business deals in place with various service providers in different geographies, so we can leverage it as a single point of integration. You don't have to work with AT&T or Verizon or separate service providers in different geographies. Integrating with Jasper just give you that seamless access. And together, they are going to lead to a different scale of digital transformation. We are working with few startups for accurate location and positioning as well. So GPS is not the most reliable source in different environments. In fact, in urban canyons in San Francisco, New York-like areas where tall buildings are obvious, so there GPS accuracy is like from anyway, the error is from few meters to like tens or hundreds of meters in certain cases. So you cannot rely on GPS for accurate drone flight operations. So there are some other technologies which are evolving, which allow us to have accurate centimeter level precision and positioning in absence of GPS. So how can you leverage those technologies to have this digital transformation covering the entire like communities, cities, and everywhere? So that's like a big grand vision we want to strive towards. And as part of that vision, if you look at the previous one, so we have this like the first phase, the platform, that itself is made up of three components. And just this morning in bathroom, I caught a term, it's like BBC. It's bird, box, and connectivity. So those are the three components. So what typically goes into the edge box? So edge box is the box that can fit on any drones, irrespective of the manufacturer, irrespective of what it is, and it can provide certain set of capabilities so that you don't have to worry about those things. So that heavy lifting of mundane tasks is taken care of by this edge box. So it can manage all the sensors, not just the camera, but providing any other sensors and offer sensor fusion and APIs right out of the box. One key application could be the area or entity of interest. So for example, you are filming through drone a huge crowd and you spot some interesting person or interesting entity within that field of view. How do you instruct a drone to keep a focus and zoom factor and hover around that automatically? So those algorithms can be coded inside that little box, which would do it automatically without human interventions. It can do it if you find, say, President Obama in a crowd, you want to always film him, obviously. So then the drone will keep on hovering around that, keep the angle and zoom factor appropriate so that the field of view is always whatever the person or entity of interest. So that's just like a one small feature of this box. Other is like it could be making adaptations in the real-time flight path based on environmental conditions or based on this entity of interest conditions also. If like there is too much of wind in a given area, like you don't want to debug in case of a live event in production scenario, like, okay, what is the next best position? You let machine figure it out. What is the next best angle and position given the current situation, current weather conditions, and current scenario? and let it do it on its own, and you just approve or decline and ask it to find a better position if you're not happy with it. So put machine to work instead of leveraging the human bandwidth at every single point. You can always do computer vision and deep learning stuff like finding out, say, safety, security, and surveillance applications. They say, oh, finding out a terrorist, for example, in a crowd, some facial recognition. So you can have those optimized algorithms run on this little box, on the bird. And you can have decision support and obviously the rules engine there. But in addition to that, in the flight, the feature set, there are flight operations also that go along with the feature capabilities. For example, what happens, you might have seen a lot of YouTube videos about like failed drone operations where just they were relying on one controller, or the battery suddenly drops the power because of the altitude and because of the temperature at ski resorts and all, and just like a falls crashing down right on the players. So those accidents can be avoided by redundancy in the controller, redundancy in the components, and all that. And obviously, the FAA and other regulatory body compliance needs to be ensured in whatever you're doing. Other applications and API, that's another big piece of it. But one last interesting point here is like a backup drone. For example, a drone discovers that, hey, I'm running out of battery power. I just like a 10% power left. Instead of humans making that decision, or in addition to humans making that call that, hey, if it's a live event coverage, for example, you don't want to miss out on any moment. So drone itself summons like, hey, somebody from the backup fleet, that why don't you come over and cover for me while I'm going down? So drone itself can indicate that, hey, I need another drone, and if automation is enough done at enough level, it would summon a backup drone to cover for it, and while it goes out for recharging on its own. So those kind of things are definitely possible in the future using the box part of the solution. And the smart connectivity, as we were saying earlier, it's like IP mesh relay, not just among the drones themselves. You can have multiple drones capturing a certain area, certain geography, certain event. You need to have coordination among all those things for, okay, somebody might be capturing like at a zoomed in level, and somebody might be capturing at a more of macro level. So how do you coordinate all those things? Single human operator cannot do all of this on his own, or rather his or her skill set could be leveraged in something else and let machines do the heavy lifting piece. But other part is like this multi-stream digital coverage. So you could have very high definition, high power Wi-Fi coverage, like high bandwidth requirement. You can go 4K or 1080p over Wi-Fi if Wi-Fi is a possibility. And you can have a low bandwidth over LTE for remote viewers. So somebody not local could still view it, and it could involve some sort of few milliseconds of latency also, but that's okay for that particular set of viewers. But for local viewers, you have multiple streams, one very high resolution, high bandwidth over Wi-Fi, and other one over LTE or 3G, 4G, or satellite, whatever is the backend communication. But at the end of the day, you need to have some sort of a graceful degradation in communication. You cannot just rely on always one part of the communication. And the collaborative airspace management. A lot of times we see in the media reports that, hey, so-and-so guy was flying a drone and it interfered with the wildfires and the rescue teams, or it kind of flew into the airplane. How can you prevent those sort of disasters? So intelligent drone platforms, that's one way of doing it. And in fact, you can collaborate. So hobbyist drones can actually collaborate and help the first responders. And we'll see in a slide later on how can they do that quickly. That's the one paradigm. And then we move to the ground station, the fog computing paradigm. A lot of heavy lifting can be done at that station, which is sitting on the ground. Irrespective of the cloud backhaul connectivity, you can do a lot of processing, especially for real-time or semi-real-time broadcasting. And they can be just like a solar or wind-powered, self-dependent stations. But they can take care of the entire fleet management of multiple drones, like how to set the angles, how to do, where to focus, and the feed persistence, so that there is at least some continuous coverage, some feed always comes through using this fleet of drones. All those policies can be enforced and ensured by this fog computing systems. You can do even live 3D modeling for situational awareness in case of disaster or other responses. Another interesting perspective is like combination, the third bullet from the last is an interesting perspective, like a combination of scout and production drones for path sharing. So if you want to say film a certain area, you don't know what the angles would be or how it would look like. So you first send a small drone fleet, like a tiny ones with this highly nimble, highly agile. They can figure out, okay, what would be the best angle and best path to fly around. They can dump all that data into these fog nodes on the ground, which can later on upload the same data to the production version drones, which are much more heavyweight, not so nimble, not so agile, carrying the heavy production camera. They don't have to hunt around what is the right angle and right path and all. They can just take in the intelligence from the scouting drones and figure it out and start shooting. Actually, so you bring down the downtime, and you increase the efficiency and the flight time of those heavyweight production drones. So there are a number of such intelligent use cases that can be enabled by this scalable platform architecture that we are working towards, starting from the bird to the edge to fog to the cloud, all the way. But it enables various vertical applications. So cinema, media, live event, that's obviously the biggest domain. But in addition to that, another big domain for drones applications is precision agriculture, because typically human presence is not much in the distant fields. So drones are basically becoming more and more popular as we move along. Remote inspection, windmill inspections, cellular tower inspections, dams, bridges, oil rigs, difficult to reach places. Drones are becoming more and more powerful, more and more valuable for those inspections. Public safety and security. For example, Super Bowl event in Cisco's neighborhood at Levi Stadium, their Cisco TAC Ops team was on standby for communication and infrastructure in case something went wrong. So we were there kind of providing as a backup fall behind support in case the core infrastructure collapsed for whatever reason. So public safety and security, ensuring those using drone operations, that also can be leveraged using the same platform paradigm. And regulatory compliance, I mean, there's no second thoughts on that. You have to be compliant to all parties and work with the stakeholders, NASA, FAA, insurance providers, liability coverage agencies, and all. So this is just like one example of collaborative media coverage. So on one side, there are fire responders in the black, and they are trying to come out with their own drones and try to capture the footage and help the victims or people who are stuck in that area in a particular building fire or something. And on the right-hand side, there may be some the media coverage or hobbyist drones, who knows. But they are flying. Typically what happens is you seal the airspace in such a scenario that nobody else should be able to fly. But that's much more restrictive than it needs to be. You can actually selectively open the airspace and get those hobbyists or media agencies to cover the event, cover the place, in response that yes, they should be willing to share their footage for humanitarian needs to the first responder agencies. So there could be a win-win scenario, but there has to be a platform that facilitates this kind of a win-win scenario, this kind of a coordination, because in case of a disaster or in case of first responder things, you cannot wait until last moment for achieving these levels of coordination. It has to be pre-planned, premeditated, pre-orchestrated. So in terms of roadmap, like certain pieces are already ready and we are building towards them. Certain pieces are coming down the road. So one is obviously this multi-sensor digital streaming edge box. It's almost ready as we speak. And smart connectivity and fog solutions are ready, and we are doing a number of proof of concept projects with media partners and other partners. But the next phase is to open up the API and the developer ecosystem, work with broad-based set of partners, service providers, and leverage Cisco's 9 global innovation centers throughout the world, and recruit the local talent, tap into the local resources, and enable a distributed ecosystem there. Participate in the consortia and academic efforts as well along the way. And the third phase would be obviously the massive scaling at the infrastructure level in a ubiquitous manner. So any drone from anywhere to anywhere, and we are talking and we are hearing a lot of things about the delivery drones by specific companies, obviously, but the limitation is humongous at this stage. The point-to-point traffic coordination just among the drones itself is big enough a challenge. And also, on top of that, not interfering with manned aircrafts, the FAA guidelines. I mean, that's like a really big challenge. So how do you enable this distributed infrastructure? If drones are delivering at like 100 miles, I mean, today they cannot fly probably by both by technological restrictions as well as by regulatory restrictions. So they have to kind of recharge themselves from speaking from technology perspective. They have to recharge themselves like a fill up gas along the way. So how do you convert the massive infrastructure which is deployed today into Tesla-like distributed charging stations for drones? So all those ideas are going to enable a more wider, more broader, much more interesting ecosystem as we move forward. And with that, thanks a lot for your time. And maybe we have a few minutes for a couple of questions. If not, we can chat later on as well after the session.
Does anyone have any questions they'd like to ask? No, okay.
All right. Thank you very much once again.